Hi guys, today you guys are going to start the next unit, Unit 8, and that's on exponential growth and decay. So just a couple real world examples before we get into the note sheet. Here are a couple just real world examples of when you have relationships that are increasing rapidly. That would be exponential growth, it's increasing exponentially, or decreasing exponentially. So here's one example. I'm not going to read through the whole thing, but it's about the volume of sound decreasing as you step away from the music. So this would be the relationship between your distance from the source and the intensity of the music. So as you step away, it's exponentially decreasing in the volume of sound. You barely hear it anymore. Another example, exponential growth. Bacteria, if you guys take your science courses, you guys know that bacteria can multiply and exponentially grow depending on what you're looking at. And we can even look at today's unfortunate real-world example of coronavirus. So you have the exponential growth of the number of cases. It went up so high, we didn't even expect that or see it coming. So those are just a couple real-world examples before we get to some of the procedural part of this unit. The first one is a warm-up. It says use your graphing calculator to match each exponential function with its graph. So you can use Desmos or you can use the online graphing calculator that I sent out one of the first days of distance learning, and you can also use your own graphing calculator. I'm going to show you with Desmos and with a graphing calculator so that you can use either or. So we're matching A and B to 1 and 2. So the first one I'm going to use is Desmos. If I want to graph that first function, I have it up here, but I just want to show you how you would type it in. There's parentheses and everything you need here, but this would be 2, and then this a to the b, it says a to the b, that button right there. You would click that, it goes to the exponent, and then you put the variable you want, x. So we know this function, it clearly shows from left to right that the relationship between x and y, you're increasing on the function. A is number 1. And now let's just double check number 2. So I'm just going to write A next to it, and we're going to look at number 2. Number 2 I'm going to do with the graphing calculator. But you're going to hit the y equals button. You're going to type into y1. So you have to use parentheses. 1 divided by 2, which is 1/2. Close your parentheses. Caret key to the power of x is next to alpha. And then you can hit graph, and there is an exponential decay function worksheet, and we know that this one is B. It is decreasing from left to right. Okay, so a formal definition: an exponential function is a function with the general form f of x, which you guys usually write as y equals a times b to the power of x, where x is a real number, a cannot be 0, b has to be greater than 0, and b cannot equal 1. Just a couple rules for these to be exponential functions. I don't do much of it in this worksheet, but you have to know that this part in the parentheses b, that's called a growth or decay factor, so I would add that in right here. And I'll show you when it can be asked. Number 1, it says determine if the function's growth or decay. So a relationship you should probably write down here is that when B is greater than 1, it's an exponential growth function. And when B is between 0 and 1, we're looking at exponential decay. And those are the two cases we're looking at in today's lesson. So for the first one, 4 is the number inside your parentheses. Since 4 is greater than 1, this is exponential growth. If I asked you, and I'm going to do this for this one so that you know how to do it for the homework, if I asked you for the growth or decay factor, you would say that the growth factor is 4. That's how you would answer that question. Number 2, 3/4. If you don't know what 3/4 is as a decimal, or you don't know if a fraction is greater or less than 1, you can simply plug it into your calculator. If you did 3 divided by 4, you would get 0.75. And 0.75 is smaller than 1. So this is exponential decay. Here, 2, there is no parentheses. They usually only put parentheses if there's a number on the outside, a coefficient, a. So in this case, 2 is bigger than 1, so we're looking at exponential growth. And 3 over 2, or 3/2, is 1.5, which we know is bigger than 1, so that's exponential growth. Okay, in the next part, we look at tables to see which one represents an exponential or a linear function. So we know linear functions are just a straight line. Exponential is what we're looking at in today's unit, but it's good to be able to compare the two. So here's how we do it. So just to review, for a linear function and even an exponential function, you want to check that we're going up by the same value for the x's each time. So +1, +1, +1. We're good. Now check your y's. If it's linear, there's going to be a constant rate of change that you're adding or subtracting. If it's exponential, you'll notice you're multiplying by the same number each time. I'm going to erase that just so that we have space. So for the first one, we added 1 each time. Now we check the y's. Are we subtracting 4 each time? -4, -2, that's not linear. So now let's check, are we multiplying by the same number each time? The most easy way to do this for each of these, because sometimes they get confusing with decimals, my suggestion is divide the next term in the y's by the term before it. So I would type in my calculator 4 divided by 8. If I type this into my calculator, I'm going to get 0.5. That shows me what I'm multiplying by each time. But we have to check the next one to see if it's constant. So 2 divided by 4 is also 0.5. So that means I would multiply to get to the next term by 0.5. 1 divided by 2 is also 0.5. We are constantly multiplying by a half each time, and therefore we know this is exponential. And the next one, the x's go up by 1 each time, which is great. So now we check the y's. In this case, we're adding 4. Let's see if it happens again. Yep, add 4 and add 4. So we know this is linear. Number 3, we're going up by 1 in the x's, which is great. Check your y's. So for the y's, if I subtract 3, we get to 9. If I subtract 3 again, we get to 9, and it works each time. So this is a linear function again. And last but not least, here you can test it and see if you can add each time, but it's not going to be consistent. So now we check multiplication. In your calculators, if you want me to show you, 0.5 divided by 1.25. 0.5 divided by 0.125 is 4. The next one is going to be 2, so 2 divided by 0.5 is also 4. And we find that to get to the next term, we multiply by 4. And we know then that's an exponential function. The next one, evaluate the function for the given value of x. Now they're giving you guys an x value, and they give you a function. So what that means to evaluate, you're going to plug in the x value they give you into the x of the function. So in this case, y is equal to 3 to the power of, and they say x is 5. You have to use parentheses if you have any fractions, so be careful with that. So this is equal to 243. The next one, I'll show you with parentheses, but it's 1/4 to the power of 3. Parentheses, 1 divided by 4, close parentheses, to the power of 3. Math, it's right here. Fraction, on the top, enter, 1 over 64. Please box your final answers. And the last one, 3 times 4 to the power of 4. Okay. Last part is graphing, and I wrote a couple parts I would like you to do for these. So the first one is determine first if the function is an exponential growth or a decay function. So we look at the b value. In this case, it's 2. 2 is bigger than 1, so we know this is an exponential growth function. Part B is graphing. So when we graph, we can use a calculator, or you can do it by hand. So just to show you a way you can do it by hand, make your table, which is part C. That should have come before the graphing. X comma Y. And the first thing I actually want you guys to try to find is what's your y-intercept. And we know y-intercept is when your x value is 0. So let's see what happens when we plug in 0. On the side, do the work. Y equals 2 to the power of 0. Any number to the power of 0, you could check it in your calculator, is always 1. So we have a little point at 0, 1. Now I'm going to show you how to get the rest of the points. You can still do it by hand. You're going to go to y equals, type in your function. So in this case, it's 2 to the power of x. And I will show you how to do this on Desmos as well. Hit second graph to see the table. And now you have all the values you need. So get, again, a couple negatives, a couple positives. Again, by hand, if you did this, 2 to the power of 1 is 2. 2 to the power of 2 is 4. And we plot our points. It's going to be a little tough to do this because you're estimating. Try your best. Negative 1 comma 0.5 will fall right there. Negative 2 comma 1/4 will fall right below it. And 1 comma 2. And 2, 4. Now we know the shapes of these graphs. Go back to 1 and 2. All of them generally form this exponential decay or an exponential growth. I actually should have been more specific. When you guys draw these, they don't touch the x-axis. It's called an asymptote, which you're going to learn a little more in Algebra 2. But it's this line that our graph gets super, super close to, but it never really touches. It approaches 0, but it never touches it. And in this case, that's our asymptote. We know now we can kind of go through and identify our parts, A, B, and C. So we have, it's the function, we have the graph now, we made a table. Let's find the domain and range. The domain is all possible x values. In this case, it goes all the way to the left and the right if we continue this graph. So we're going to write down all real numbers. And for the y's, the range, the lowest point the graph touches on the y now we're looking at would be not 0, but almost 0, up until infinity because of this arrow right here. It goes on forever. So when we write this, we have to be careful. It never touches the line y is equal to 0. So when we do this, we have to be careful with our inequalities. Y is greater than, not equal to. We don't have this symbol here. 0. And that is part D. And lastly is E, which we already found. First thing we did was the y-intercept. When you plug in 0, you get 1. So that's our y-intercept. Let's do that again, but now let's do that with Desmos. So here's a function. 2 parentheses 0.4, just like it is in the on the worksheet. a to the power of b right here brings it up there, and you put an x in the exponent, which for some reason it's not letting me do. There we go. And I think it was plus 1, but I want to double. We have this graph. We now know how it looks, the shape of it, but I want specific table values. So you're going to click this setting button up here. There's a table picture right next to the function. Click on it. And there are your values. I personally like a Desmos. It is important to know how to use a graphing calculator, but Desmos sometimes gives you a nice conceptual visual. So here are your values. Put them in the table on your paper, and start graphing those points. Estimate's going to go a little on top of the graph. That's okay. -1,6. 0, 3. Notice that 0, 3 is going to be the y-intercept we have to write down. 1, 1.8. 2, 1.32. Go back to that graph. In this case, because of this +1 at the end, our asymptote, that line, y equals a number, changed to being y equals 1 because this graph was shifted up 1. That's just an important piece to know. So if I actually zoomed in at that line y equals 1, it looked like it touched -1, but it never does. It just almost reaches it. So that's going to help us with the range when we talk about range. When you guys graph it, just be careful not to hit that line. Try your best, it's difficult. Almost touches it, but never really does. And add your arrows in. As you can see, this function is decreasing, so we say it's an exponential decay, and we know that from the b value. So part A, this is exponential decay. Part B is done too. I think that was the table. That was a graph, and C is a table, so B and C are done. D was your domain and your range. So in this case, what's the domain? We're going to the left forever. That's that arrow, and to the right forever. So we say the domain is all real numbers. And the range is all the possible y values. We know it never really touches 1, so it's all the possible y values bigger than 1, not equal to. This arrow up here tells us it goes up forever. Okay. I'm not going to do the other two graphs with you, but I am going to show them to you just to make sure you're on the right page. So number 2 and 3 on Desmos would be, let me take that one off. There's number 2. It's an exponential growth. Y-intercept ends up being 0, 2. You can find a couple other points here. That's 1/2 to the power of x, and that's an exponential decay. If you click right here, your y-intercept ends up being 0, 1. You can try those on your own if you would like, or you can just begin the practice.